Section 10.1, this first part, we're going to look at comparing two different populations to each other. So looking to see if there is a difference between two different populations. So we'll look at this example. At school 1, 70% of students did their homework last night. At school 2, 50%. All right, so that is like our proportion or population numbers. So now we want to check to see what that difference is. And so the counselor at school 1 takes a sample of 100 students and records that proportion. And the counselor at school 2 takes a sample of 200 students. All right, so just to kind of solidify our symbols here. Okay, so we're using P1 and P2 for those population proportions, and we're using 1 and 2. Sometimes if it makes more sense to use letters, like if it was like, I don't know, Patriot and Battlefield, so it would be like PP and then PB, something like that, but not always. And then our statistic, of course, is P hat 1, P hat 2. And then we have our two different sample sizes. So everything is denoted with a little 1 or 2 to say which sample or population it comes from. All right, so let's review sampling distributions, okay? We have to be able to identify the shape, the center, and the variability. All right, so the shape is approximately normal as long as we meet that large counts condition. All right, the center, the mean of the sampling distribution is the population value. And then the standard deviation, we have this formula. And we can only use this formula when we meet the 10% condition. So how can we do that same thing, figure out the characteristics of the sampling distribution for P1 minus P2 for the difference in our proportions, okay? Back in chapter 6, we talked about the rules for combining random variables, which is what we're doing here. We're combining two sample proportions. So for the mean, all right, if we are subtracting here, then we can just subtract the two means. So for our sample proportions, we take the population proportion. So in this case, it was 0.7 minus 0.5. So the mean of this sampling distribution is 0.2. Okay, then for the standard deviation, remember that we had to square each standard deviation, add them together always, even though this is subtraction, and then take the square root at the end. So this is the standard deviation of proportion 1. This is the standard deviation of proportion 2. All right, and we're going to square those. Because they have a square root in the formula and then we are squaring them, it simplifies down to just one big square root with each of these two fractions, because this square root and that squared cancel each other out. This square root and that squared cancel each other out. Okay, and then we're plugging in numbers. All right, so we have a mean for this sampling distribution of 0.2 and a standard deviation of 0.058. Okay. So just to kind of sum it up, all right, one thing is we have to have two independent samples, okay? So the way that we get our sample from population 1 cannot have any effect on the way we get our sample from population 2. There can't be any overlap between them, all right? So the sampling distribution is approximately normal as long as the large counts condition is met for both samples. So you have to do n times p and n times 1 minus p for both schools here in this case, and all 4 of those numbers have to be greater than 10. All right, the mean is just the two proportions subtracted, okay, population proportion. And then the standard deviation, we would use this formula, but we have to check that the 10% condition is met for both of our samples. So this whole chapter, while we're doing differences, we got to check things for both samples. All right, so let's run through an example. Okay, you can pause and read this. Okay, so for the shape of the sampling distribution, we're checking large counts. Okay, so n1 times p1 and n1 times 1 minus p1. And then do the same thing for the second school. All of these numbers are bigger than 10, so the sampling distribution is approximately normal. Then when we want the mean of the sampling distribution, we're looking at our two population numbers. So bag 1 was 0.25, 25% red crackers, and bag 2 was 35%. So 0.25 minus 0.35 is negative 0.1. And then the standard deviation, we are going to plug everything into this formula. But before we do that, we have to check that both samples meet the 10% condition. So 50 is less than 10% of bag 1 because it says each bag has more than 1,000 crackers. And then 40 is less than 10% of bag 2. So then we can plug in our numbers, and there's our standard deviation. Okay, for the interpretation part, we're going to say the difference, and you need to indicate the direction of the subtraction. So bag 1 minus bag 2 in the sample proportions of red goldfish crackers, that's all just giving context, typically varies by about 0.097 from the true difference in proportions of negative 0.10, okay? So the second half of that sentence should look really familiar because it's the same as we did for standard deviation from one sample in the past, okay? We just need in our context to say that we're talking about the difference and give the direction of the subtraction. We can also create confidence intervals for that difference. And again, we have 3 conditions here that we have to check. So, and these conditions are going to look very, very familiar. All right, random sample, okay? And both of our samples have to be random and independent. So when you're writing this condition, we have to say that the samples were independent and that both of them are random, okay? 10% condition, again, for both samples, and then large counts for both samples. So, okay, doing the actual math for the confidence interval, it is the same as when we did confidence intervals for one proportion. So our statistic plus or minus that critical value, which is Z star for proportions, times the standard error. Remember, the only difference between standard error and standard deviation is we acknowledge that we're using sample data, so p hat, because we don't have population data. Okay, you would find that Z star the same way that we did with one proportion. So you're doing the inverse norm with the area to the left. Okay, so you can do it this way where you can find the difference and then plus and minus your margin of error. Or we can also use the calculator just like we did before. This time, make sure that you are doing a 2-sample Z interval. Okay, and then there are your directions. So, and the Casio, when you get to the Z, just make sure you pick 2p. Last time we did 1p. And then on the TI, it's option B, a 2-proportion Z interval, whereas last time we did 1 proportion. Okay, so let's go through an example and actually put together our confidence interval. Okay, so you can pause and read this question so that you have an idea. All right, and one thing that we're going to note here is sometimes we do confidence intervals from sample data and sometimes we do them from experiment data. And so when we do experiment data, there's 2 things. One is we usually do not need to check the 10% condition because we usually don't pick experimental units from some larger population. Like we have all 57 and we put them in a group and all 55. So we're not like picking from some larger group. The other thing is when we get to the conclusion part, typically when we have human subjects in an experiment, they are either volunteers or we went out and recruited them. So we can't, because they weren't randomly selected from the population at large, we can't generalize the results to the whole population, but we can use this phrase, people like those in the experiment. So you'll see this here in our next thing. So we're going to construct and interpret that confidence interval. Okay, so we're going to do a 99% confidence interval for P1 minus P2, and then we're going to define our proportions. So P1 is the true proportion of patients, and see this phrase, like these. That's how we account for that fact that our patients weren't randomly selected. Who would report reduced lower back pain after taking naproxen and Valium, and then P2 is naproxen and a placebo. So again, the only difference is in those experiments, we're going to use that phrase like these when we're defining our proportions and when we're writing our conclusion. Okay, so state plan. All right, we're doing a 2-sample Z interval for P1 minus P2. Okay, our random condition, the patients were randomly assigned. Our large counts condition, we're going to check those. So n times p, n times 1 minus p, we get 18, 43, and then for the second one, 12. And where's my fourth number? Oh, 39. Okay, so all of these are greater than 10, so we're good there. And then like we just talked about, we do not need to check the 10% condition because we weren't taking these patients randomly from some larger population. All right, then we get to the do step. And again, you have a choice. You can use the formula, all right? So we plug in here, or you can use your calculator. If you use the calculator, I want you to tell me these 4 things. What was p hat 1, p hat 2? What was n1? What was n2? Okay, and that's how we get, that's how you show your work calculator-wise. Okay, so either show me the formula with numbers plugged in, or show me what you entered into the calculator. Either one of those would be acceptable. Okay, so now we have our interval, and then for our conclude part, it's going to be similar to the conclusions that we wrote for one sample confidence intervals. All right, we are 99% confident that the interval from captures P1 minus P2, which is, and then we need to define what P1 minus P2 is, the difference in the true proportions. And again, we're using like that phrase like these because it's from an experiment. Okay. All right, then the second question, based on the confidence interval in part A, what conclusion would you make? All right, so the interval includes 0, right? It goes from negative 0.3 to 0.11. Okay, so that means that we don't really have convincing evidence that taking Valium affects pain relief, all right? Because if 0 is in our interval, that means there's a possibility that there is no difference between Valium and the placebo, so we cannot conclude that it affects pain relief. Okay, and that's it for 10.1 part A.